Good afternoon. Today, it's a projectile motion practice party. All right. So you have this projectile motion practice page, and we're going to do a few sample questions trying to figure out how do we figure out where a ball hits the floor if we send it horizontally off of a table. So just to give you a feel for what that looks like, here we go. I have a ball. I would send it horizontally off the table and we would figure out where it falls. Ready? Oh, there it goes. Okay, so I could figure out how fast it was going horizontally on the tabletop. I could figure out how tall the tabletop is, and then I want to project how far away from the tabletop is the object going to hit. Okay, so this is kind of a classic problem. So let's go through and see what we can do. So we're going to determine where the ball hit the floor. I'm going to start by figuring out my needs and my givens. So I've got my diagram here, and I know what's going to happen is the ball is going to come off and come down like this, and then it's going to hit the floor. Here's the floor. I'm going to assume it's flat, and I want to know how far is that. So that's how far means it's a distance. Right, so I know that that's going to be a distance, and it's horizontal, right, off the table. So it's going to be a distance horizontal. Now, height, how tall the cliff is, would also be a distance. It's measured in meters, so that's going to be a distance. But that one's going to be an up and down distance, so it's going to be a distance vertical. And then finally, over here, I have my velocity of 12 meters per second, and I can see that the ball is traveling sideways, and that would be a horizontal velocity. So if I summarize, what I need is the distance horizontal. I'm given two values. I'm given the distance vertical, and that was 5 meters. And then I'm given the velocity horizontal, which is 12 meters per second. Okay, so the first thing that I have to remember is that I have to treat horizontal and vertical as independent, meaning I can't mix and match between them. The one thing that is consistent for both of those is time, because time isn't horizontal and time's not vertical. Time is universal, let's say. So what I'm going to do is I'm going to start by figuring out how would I find my horizontal distance. Well, I've got my horizontal velocity, so I think I would do velocity horizontal equals the distance horizontal over the time. And in this case, it would be the time of the fall. Okay. So distance horizontal, that's what I'm solving for, right? So that is good. Horizontal velocity there is 12 meters per second. And then I need to find the time of the fall. Okay, so now I have a new need, right? My new need over here, now I need a time of the fall. Now I know that falling time is controlled by vertical motion, right? Because it's falling vertically and it falls due to gravity, right? Acceleration due to gravity. So I have a vertical distance. I know acceleration due to gravity because I always know acceleration due to gravity. So it's not given to me, but I know that acceleration due to gravity is 9.8 meters per second squared, and I need time. So I would go and check on my physics everything sheet, and I have an equation for vertical distance, and that equation for vertical distance is distance vertical equals 1/2 acceleration due to gravity times the time of the fall squared. Okay, so now I can plug in the values that I have. I've got a vertical distance that can go in there. I've got an acceleration due to gravity that can go in there, and that'll leave me with my time, which is what I want. So when I plug in those values, I'm going to see 5 meters equals 1/2 times 9.8 meters per second squared times the time squared. And it's the falling time, but I've left off the subscript because it's now the only thing that I'm solving for. All right. So half of 9.8, 1/2 times 9.8 is 4.9. Doing that one in my head. So I could divide both sides by 4.9 meters per second squared, divide by 4.9 meters per second squared. Meters on top, meters on bottom, those are going to cancel. That whole thing is going to cancel. So I'm left with 5 divided by 4.9. Second squared will flip to the top. So I have t squared equals, and I'm going to use my calculator, 5 divided by 4.9. It'll be really close to 1, but just in case, 1.02. 1.02 seconds squared. So now to get t by itself, it's currently squared. I have to take a square root of the time and do the square root on the other side as well. And I'll find that the time equals square root of my previous answer, 1.01 seconds. Okay, so now I can take my 1.01 seconds because the time that it's falling is going to be equal to the time that it's in the air, which is the time that it's moving horizontally. That time can go in there. The velocity horizontal can go in there, and that leaves me with my horizontal distance, which is what I'm solving for. So let's plug in there. That gives me, let's see, 12 meters per second equals distance horizontal over 1.01 seconds. To get distance by itself, I'm going to have to multiply both sides by 1.01 seconds. That'll cancel, and I'll get distance horizontal equals 12 times 1.01, 12.12. But in this case, my numbers were given to me in 2 digits. 12, 5 is only 1 digit. So I'm just going to give my answer in 2 digits. 12.12 is equivalent to 12 meters. And that is my final answer. Okay, so let me just go back and I'll show you what that sequence of steps was so that we can make sure that we got it all right. So number 1, I identified my needs and my givens. That's in black. Okay. Number 2, I set up the equation that I wanted to use for horizontal distance or horizontal velocity. Number 3, I moved over here and did my vertical distance equation. So that was all this vertical stuff coming down here to find the time. And then number 4, I came back, plugged into my original equation, and solved. So that's a nice little 4-step problem to get my total answer of 12 meters away from this edge of the cliff. Okay, so you go ahead and try solving number 2 by yourself, then shift on and solve number 3. One note on number 3, note that the height is 10 centimeters, and you want the answer, or you want that to be in meters. So remember, there are 100 centimeters in a meter, so 10 centimeters is 0.1 meters, hint, hint, for that vertical distance. And then number 4, it's the same problem. The only thing that's changed is now you're solving for horizontal speed, which was that part, right? V sub h, horizontal speed. And you're given the horizontal distance. So you're given the distance horizontal as 15 meters. you're solving for the speed. The first part of it is exactly the same, and then you're just plugging in a different one. Okay. And then finally, you're going to answer this set of 5 analysis questions. And then the key will be posted for you. All right. Have fun working away on those. Enjoy.